Efendim malum haliniz dünyada oradan bir şey geliyor, buradan bir şey gidiyor. O nasıl oluyor? Uçakla oluyor, gemiyle oluyor, tırla oluyor, bilmem neyle oluyor. Bizde bazı mal yok, öbüründe o mal var. Bizde bazı mal çok, öbüründe o yok. Bunlar konteynerlere yükleniyorlar, güvenli bir şekilde geliyorlar. Herkesin malumu. Bu konteyner işinin bizim sektörle de alakası yok mu? Var. Bak birbirine karışmıyor. Gemideki, tırdaki, konteynerin içindeki mallar birbirine karışmıyor. Birinde et var, birinde süt var. Birbirini bozmuyor. Hepsi kendi benim korunma protokolleriyle geliyorlar ve bizim oluyorlar. Hayatımızı kolaylaştırıyorlar. Bizim sektörde de yazılımcı arkadaşların e, konteynerleri kullandığı çok açık. Ama yazılımcı arkadaşların işine yarayan bu iş güvenlikçi arkadaşların saçının başını yolmasına sebep oluyor. Çünkü onlara da güvenli gelmiyor. Şimdi bir abimiz var. John Morello. Palo Alto Networks'ten bu işi çözmüş. Sakin olun diyor ya. Sen bir çekil diyor bana. Ben bir anlatayım. Göreceksin ki diyor. Yani hem yazılımcı hem güvenlikçi için bu konteyner nasıl kullanılır ve verimli olur ben anlatacağım diyor. Efendim karmaşadan basitliğe mevzunun başlığı ve bizim de buna çok ihtiyacımız var. John Morello'yu dinleyelim, işi çözelim hadi.
John, welcome. It is great to have you on our virtual stage. Thank you for accepting my invite, my friend. Thank you.
No problem. Thanks for having me. I enjoy being here.
Thank you. I mean, you have built a great success story. I mean, looking at your background, 13 years in Microsoft and becoming a CISO, but after then, with your friends from Microsoft, Ben and Dima, you founded Twistlock in 2015 July, right? Please correct me if I'm wrong. And it was built to provide container security, which has been acquired by Palo Alto in 2019. So it was a great story, my friend. Congratulations. Containers are, it is easy to say, more dynamic, more flexible, but of course at the price of infrastructure complexity, and of course, which is also challenging the traditional security practices. So container adoption demands comprehensive protection, right? I mean, and they are differing from the legacy platform. So it means that the security has to differ from the legacy security. So how did containers change the security paradigm? How does traditional application security need to be reimagined in the container world?
Well, I always think it's a good question. It's one that we've talked about, many times over the years, of course. And I always like to describe the answer that as containers, like with any new technology, bring advantages and disadvantages if you're either the defender or the attacker. So it's not like with any other technology. You see things that are both easier and better and things that are harder and more difficult that come along with it. And so if you're the defender, if you're the person trying to protect the environment, there's some things with containers that you get the opportunity to do security a better way. So containers have three fundamental characteristics that give you that opportunity to do security more efficiently and more effectively. The first is that containers are declarative by nature. So instead of a developer like kind of building their application and not having like any readable way to really understand how does it behave, what's inside of it, containers, like the whole notion of how images are built and developers create them, lends itself towards like this declarative model where you can look at this image and say it includes this software of this version, it runs this process, it listens on this port, etc. So it's much more possible for security software to read that information out of the image and understand like what the normal behavior of it is. Secondly is that containers are designed to be predictable at runtime. In other words, that image that you deploy shouldn't dramatically change what it does over time. You know, if you starts off running a particular version of Nginx and you want to update that version, you don't SSH to the container and do that. You destroy that container and provision a brand new one that includes an updated image with the updated version of Nginx. And that might seem like a small or kind of a technical aspect of it, but it's really important because it allows you to have security software that can learn what the real state, what the normal behavior of that thing is at runtime, and then to be able to automatically find anomalies relative to what that model predicts. And so you can more effectively determine when things are going bad without people having to create a bunch of rules for that. And then finally, the third major characteristic is that they're minimalistic. And what I mean by that is, instead of like a virtual machine image where you have like a full OS and a big application stack and data and configuration, all this other stuff sitting in there, that might be tens of gigs, and it's very difficult for software to effectively go through it and understand the components and how they behave. You know, container images might just be a few hundred megs or even a few tens of megs, and so it becomes actually possible and realistic for software to go and create a model, to understand what's inside of it, to know what to do. So those three characteristics, the declarative, predictable, minimalistic nature, enable you to build security tools that remove a lot of the human interaction that's required to manage the security posture and rules and allow you to do it in a more efficient way. So that's the opportunity to do security better. And obviously you have to take advantage of that opportunity. It's not just because you use containers, you automatically become more secure, but the opportunity is there. Now, the second half of your question was, you know, like what's easier and what's harder. There's also some things that containers make harder about security. First of them is that you have a lot more entities. You know, instead of like a typical free-tiered application might have 3 VMs that run the application, if you could decompose that into microservices and containers, you might now have dozens of different things that are all working together to run that application, but it's more things that have to be managed and more things that have to be secured. Additionally, those things change much more frequently. You know, one of the reasons people adopt containers is they want to be able to deploy their software more efficiently and more rapidly innovate. And so they're going to be pushing new versions of that software, not, you know, once a year as often was the case in the past, but now maybe once a month, once a week, maybe even multiple times a day. And so not only do you have more entities, but those entities change more frequently. And then the final thing is the developers themselves are now much more responsible for the security of that thing, because now the developer can literally just run a command or create a manifest and automatically have that thing deployed into a production environment in Kubernetes. Now there's not a stopgap, a point where a human operator like gets some software and goes and manually SSHs someplace and installs it. Now the pipeline's directly from the developer to production. So not only do you have more things, they change more frequently, but now the person who's responsible for securing them is much more so in the space of the developer. And so again, like with any technology, there's things that are easier, things that are harder. There's those characteristics that give you the opportunity to do security better, and then there's those few things that make the potential for doing security more difficult. And it's up to you to really balance them so that you're taking advantage of those opportunities to minimize the things that make it more difficult.
So why did Palo Alto acquire Twistlock? Why were you so valuable for them? And the other question is, what did you achieve in the last 1 year, almost over 1 year, right? So
Our vision with Palo Alto Networks is we have a platform we call Prisma Cloud, which Prisma Cloud is a cloud native security platform. We're trying to like create a completely comprehensive platform that covers everything that customers need to secure their cloud environments, both at the service plane. So how do I configure all those things that Amazon and Azure and Google and everybody else gives to me? Like, how do I make sure that my S3 bucket doesn't have anonymous access allowed when it stores PII data? All of that layer, that's service plane configuration, is what Palo Alto acquired companies like Redlock and Evident to provide that. On top of that, though, is how do you secure the applications and the compute resources that those services provide to you? How do I like make sure that the images that I deploy into a managed Kubernetes service are secure? How do I make sure that I have that CI/CD integration as I build my applications? That compute layer is why Palo Alto acquired Twistlock. You combine all that stuff together, and wow, now we're able to really have a capability that doesn't exist anywhere else in the market, which is a single platform that you as a customer can use that's multi-cloud to protect across Azure, AWS, GCP, Oracle, and that protects not just how you configure the services that those providers offer, but also how do you protect the applications that you run on top of those services and on top of their infrastructure. And so our goal with Palo Alto Networks is to have Prisma Cloud be that truly comprehensive cloud-native security platform that covers all the different providers that you use, all the different services and forms of compute that you use on top of it, and across the entire life cycle of the application. It's obviously an ambitious goal, but you know, you asked what we've done in the past year. One of the things that we've done is really try to make real progress towards that. And I think you can see through the results of what we shipped that we've done so. So beginning as early as November of last year, when we first, you know, we'd only been part of Palo Alto Networks for a few months at that point, we integrated Twistlock with Prisma Cloud. We rebranded it to Prisma Cloud Compute. We integrated the SaaS service so that you can now consume Twistlock, what's now again Prisma Cloud Compute, not just as something that you download and run yourself, but as something that you can consume as a fully hosted SaaS service. We've done lots of integration, so you have a common authorization, authentication model. We share vulnerability data across the platform, and there's lots more stuff to come. We're building some joint modules together to help developer security be improved, again, not just at the compute layer, but also at the infrastructure as code that's present within that as well. So, you know, the goal that we have with Prisma Cloud is that comprehensive multi-cloud security platform that really provides everything that you need to secure the service plane and the compute plane across the entirety of the life cycle of those assets.
It is really very exciting to see what you achieved in just 15 months, my friend. It is really exciting. But let me go one step back. I mean, let's look at the story through the big picture of SDLC so that we can put your value just in the SDLC. How good, what types of testing is needed and at what stages they should be in SDLC? What do you think?
Yeah, I think that one of the opportunities that cloud native software provides, because of that declarative nature and the focus on a software driven pipeline to get something from development all the way into production, is you now have that ability to introduce security in a very natural way very early in the life cycle, but also like throughout the entirety of the application. So, a lot of times in the past, you would have a developer would build software and they would use some kind of like static or dynamic analysis tool, and then they would ship the software and somebody else would scan it for vulnerabilities, and then somebody else would go and deploy it, and they would use a third tool to scan it for problems in production. You now have the ability, though, because of that singular pipeline and the notion that every step through there is automated, to say that you're going to have now security much earlier, literally as you build the application and you build it from some Git repo with components, you can connect to the repo, understand what's present there, analyze it, find problems there. You can do it when those things are being assembled into an executable artifact, like an image or a function. You can do the scanning at that point. You can do it once they're pushed to a registry, when they're going to be deployed from that registry later. And then really critically, one of the most valuable things is you can also enforce it at deployment time. So for example, within Prisma Cloud, we have an admission controller that's built into the product, so that every time you go to deploy applications onto your Kubernetes cluster, you can say only allow things that meet my requirements around, not running as privileged, not with critical vulnerabilities, configured with a particular way. So you can ensure that security is present from the very beginning to the time that you're deploying it, and even after deployment, in a way that's much more efficient and streamlined than what you've been able to do before, because it's all driven by software now. This notion of, a declarative model for how do you build the software and how do you provision that into production. Perfect,
man. We are all trying to shift left more and more and to security, to build secure software and to help it in the early stages, right? So how good are organizations to embed security in early stages of software development? And can you tell us about some strategies that we can achieve that goal?
Yeah, I mean, obviously, some organizations are always going to be better about security than others. So some people are quite advanced and sophisticated, and others are, are just getting started. in general, I would say that the problem there, the challenge there is less about the technology and much more about the people and process aspects. Like there's many tools from Palo Alto Networks and from many others out there that will allow you to scan things as you build them, that will allow you to look at vulnerabilities in your registry and do all the kinds of capabilities required to do secure software development. The challenge though is, how do you build those tools in a way that's efficient and friendly, basically, for the developers so that they don't look at it as this burden to be avoided, but instead as like an actual valuable tool that helps them build better software in the end. And there's a lot of dimensions to how you do that, but one of the things we always really try to focus on is to make sure that in addition to providing the security controls that security teams need, that we implement those capabilities in a way that makes sense for developers. So as an example, you can scan images and functions and hosts for that matter, not by having to install some big heavyweight agent that requires a lot of resources and is difficult to install, but instead we have a single statically compiled Golang binary for Linux, Windows, Mac OS. You can curl it via the API, get it down into your build job, and have it run instantaneously without any kind of installation and any sort of overhead. So it's very easy for a developer to make use of that. The data that tool emits, a lot of traditional vulnerability tools were built for security people that want to generate reports. So it would generate some PDF file that you have to read through with charts and all this. Well, that's not what a developer wants. A developer wants an easy way to say, okay, well, tell me the problems, and then I can automate the way of fixing it. So in addition to like us giving that data in a nice UI and a CSV file, we also make it so that you can just get a direct JSON output so that the developer can literally just run a single command line, see whether that job should pass or fail based on the vulnerabilities, and get this very consumable software artifact they can use to further automate the process of fixing them. So I guess in summary, I would say it's not so much about like, are the tools available, as it is like, are you ready organizationally to choose the tools that are efficient for your developers to use, and then to integrate those tools with the workflows that developers already have, so that it's not an additional step that they have to do manually, but instead just a natural integrated part of the way that they do every single build. It just automatically happens. Once you make it that part of just this automated flow, then it just happens without any additional thought or effort, and thus becomes much more institutionalized in the process.
What do you think, what will be the evolution of secure coding? What is the next big thing in application security, and what is the part of what is going to be the role of Palo Alto in that?
Well, I think it's less so about a single new technology as much as it is about the integration and the efficiency of integration of a lot of technologies that already exist out there today. So, people are not suffering because they don't have a tool to fit a particular, need. People are suffering, and their security is suffering because they have too many tools, and those tools don't work well together. Again, you have static code analysis tools, dynamic code analysis, software component analysis, production vulnerability management, policy admission controllers. Like, you have like no shortage of tools, but they're all very narrowly focused in what they do. Yeah. And because they're very narrowly focused, it puts a huge amount of burden on the user to figure out, well, how do I stitch all these things together? And if they ever even spend the effort to do that, as those things all evolve independently, then you'll be in situations where, something breaks and you have to go back and redo work that you thought you'd already done. So what we try to see as our goal with Palo Alto Networks is to unify that experience so that across the entire continuum for development security, you've got a consistent platform that looks at not each phase in isolation, but each phase as just a step in the overall life cycle, and allows you to express policy in a way that is application-centric, not component-centric. So instead of saying like, hey, this image, I want to have this behavior, and this other image, this other behavior, and this function, and go and configure that separately, we can say you've got this app that is composed of all these different images, some serverless functions, some infrastructure as code like CloudFormation that you use to deploy the environment. We're going to look at all that stuff together. We're going to treat that as one kind of unit that all works together. And we're going to allow you to say for every phase of the life cycle of that unit, you can have these controls in place that say, if it doesn't meet your vulnerability posture, don't allow it to progress. If it has a insecure configuration, don't allow it to progress. So it's not so much about saying that we want to invent like an entirely new kind of capability. It's not because people don't have tools today. It's because those tools don't work well together. We have that opportunity to make them really work well together and make them thus something that people can actually take advantage of to have a better security outcome than trying to stitch them all together themselves.
Yeah, I 100% agree. I mean, if unfortunately, if security is going to be continuing to be the afterthought, then we have to ease the pain for security of the complexity, right? I mean, it is big pain over there, and if we can do that, then we are going to bring in security in the speed of DevOps.
That's right. That's right.
So, my friend, thank you for your time. It was great to talk to you, and it was a great conversation. We learned a lot. You gave great information and advices. If we take away one thing from your from your advices, from the information that you have given, what do you want us to remember?
Security is more about the people and process evolution than it is about buying the latest shiny new toy. We're trying to help customers, have software that helps them integrate with that people and process layer so they can actually make use of it and get the security benefit that they really need in this new world of DevOps and cloud native.
Thank you, John. It was great to speak to you. I hope to see you soon in Istanbul on our physical stage.
I'd be happy to be there. I enjoy meeting with you guys, and thanks for having me.
Thank you, my friend. Take care.